screen recording, and hopefully that works. Changed some settings on that today, so you'll have to bear with me if there's disaster. Cool. Awesome. So today we'll be kind of building towards what our next 3 sessions will be, which will be machine learning stuff in Python. We'll be using TensorFlow. So I think the first session which is next week, will be on getting your data in the right shape for machine learning. So like, how do you take raw data and put it in something that you can train an algorithm on? That, surprisingly, at least in my experience, has been like 70% of the work. So we'll take a look at that. Then the second session will be about actually building different models. Now that I think about it, yeah, we should have time to show off at least LSTMs and CNNs, and we'll learn a bit more about what those are once we get to that point. And so we'll look at how to build the models and actually train them and get some results out of them. And then our last session will be a little bit focused around how you can optimize these networks, or maybe getting like different metrics from them to evaluate which ones are the most effective. So we'll look at things like confusion matrices and stuff like that. So that is the next sessions. This session is going to be on object-oriented programming in Python. It's just an extra little bit of complexity. I think we might have touched on classes and objects in our previous exposure to Python, but probably only briefly. But those are used, like the whole object-oriented model is used pretty intensively in lots of Python programs, including in TensorFlow. So this is kind of like a prerequisite for that, if you will. So hopefully that all goes well. That's next week, but this week, yes, object-orientedness. So we'll start with the add many things. I'll try and fly through these faster than last time around because I was a bit slow on it last time around. So first of all, I will send out the link to the little attendance form so we can know how many people show up, and we can coerce more money out of the department, as we always want, funding for Bionics. So there it is in the Google Meet, and there it is in the Discord. Yeah, just pop whatever name, as long as you're consistent with it, in there. And then, while everyone's filling that in, I also got, well, I have some news about the plans for the rest of this semester. So I put out my form, kind of asking, does anyone have any specific things they want to cover for second semester? So one of them was machine learning in LSTM neural networks, which we will hopefully be covering 2 sessions from now. I think we can fit that in with the convolutional neural networks in the same session. And then by the end of the semester, someone has also suggested if it's possible to do iForge training. We will have to see what COVID restrictions around iForge stuff are, but that would be pretty cool. That was something I originally planned on doing first semester, but, well, COVID. So didn't quite get to that the first time around. But yeah, so it was some good feedback for things to do second semester. As well as that, I've been working with the GraphCAD people. I have a meeting with, I think, Peter Marlon tomorrow, who's one of the people in GraphCAD who works kind of with Bionics as well. And he said he's happy to do a couple bootcamp sessions near the end, which is good. We can fill those extra slots if things like iForge fall through, with some special CAD sessions that are very, I guess, Bionics tailored, if you will. He might do some stuff on photogrammetry, so that's where you take a bunch of pictures and turn it into a 3D model. Or he might also do something about mesh editing for like complex shapes that are a bit more organic. So if you're designing a socket for a prosthetic, maybe. And he's got experience in that and is willing to do some sessions on it. So we might be able to see that later this semester. Yep. At the end, I'll shoot everyone a feedback form. Forgot to do that during the session last week, but these feedback forms are always up on our Bionics website, Bionics Bootcamp. And so those are always around if you do wish to roast me. So like for the 3D printing one, for example, at the very bottom is always a survey. So excellent. Boom, admin done. Oh, almost admin done. One last thing. There is, at some point in time, and I have forgotten the point in time, but I'll get back to you on that, either March or April, I think, societies do their AGMs, which are these big assemblies where they elect the next year's committee. So, I'm going to be headed into third year probably and taking on a big project there, so I might not have a ton of time myself. And other committee members are graduating and things. So all of us are looking for people who would like to run for these positions. So, I mean, of course, if you wanted to run Bootcamp, you are free to use all of the things that I have created for next year, and your own as well. You can make them even better. And of course, there's an overlap period, so even if you're not interested in like my particular role, if you're interested in any of the different roles in the society, no matter which one you're interested in, there's like a month overlap where old committee is still there, but you guys are the new committee once you're elected in. So you can be trained by the people who've been there for a while. So don't worry about not knowing enough up front if you want to run for any of these roles. Just go for it, and we'll all be very happy to help. And I will still technically be around at uni, so I'm definitely around to aid with that as well, even if somebody else is in my committee role. So just figured I'd shout that out there, and I'll probably pester people until the date of the AGM. And I'll also get back to you with the day of the AGM, unless anyone from committee in here knows the actual day of the AGM, which I think would maybe be Kate, but I'm not sure if she knows. Because I do not remember.
Sorry, I just joined.
No worries. Do you know when the AGM is for Bionics Committee?
We haven't said it yet, have we?
Well, there's your answer.
It's up to us to set it.
Okay, yeah, so we haven't said it yet. That'll probably be sometime in the next couple of months, so I'll keep you all looped in.
They're usually in April.
Cool, April. Excellent, good to know. Awesome. Yeah, so keep that in mind if you want to be on the Bionics Committee and lead a project or do one of the other roles as well, like treasurer or secretary or communications or anything, or even social officer. You can plan some fun activities for us all. Awesome. Okay, with that out of the way, I think we can jump into some object-oriented stuff. So the first thing we'll probably do is talk a little bit about what it actually means for something to be object-oriented, and in case there are people who haven't been exposed to that before, which I assume is the majority, but let's actually check. So I can do a poll in Discord, so we'll say poll have or yeah, sure, have you learned about object-oriented programming before? There we are. And then you can answer that little poll in Discord so we can get a bit of an idea. Oh, okay. A very interesting split here, actually. Cool. So actually, a decent number of people do already
disregard me, because it's not meant for me anyway.
Yeah, but okay, cool. Very neat. So I won't spend too much time dawdling on the concepts about object-oriented itself, and I'll probably focus on the Python things, trying to show them through that. But I will go over it really quickly for people who maybe aren't as familiar with it. So the idea of object-oriented programming and things like Python involves two main concepts, if you will. So you have things that are called classes. So you have a class, and then you also have objects. Oh my goodness, this is going to be some rough handwriting today, my friends. I'm sorry, I'm trying to write on a tablet, and my handwriting's not good on paper, so we're going to learn today. Awesome. So the classes, what these are is these act kind of like blueprints for objects. And objects you can think of as almost real-world objects. So to make that a bit more concrete, say you have a car class. So since it's a blueprint, we'll draw ourselves a lovely little blueprint. I don't know how to draw blueprints, so there you are. You've got your graph paper, whatever you draw blueprints on, and then you've got your little beautiful car. Welcome to art class with Brooks. Oh my lord. Be well aware that art is not one of the lessons you learn in Bootcamp. That one you're going to have to bring your own. We'll give it a 6 spoiler, though, so it'll have a nice racing wing. Look how fast this machine is. Beautiful. Trust me when I say that's a car, I guess. Good lord. So the idea is that this class of blueprint defines kind of what it means to be a car, if you will. So say if you want to just toss some things in the chat, I'll actually reopen the chat for the Google one. I closed that. There we are. What are some things that a car might have? Think about both properties of the car. Well, yeah, let's think about properties of the car first. So what might define a car? What makes some object a car? Any ideas? You can spit some things at me in either of the chats. Some defining characteristics. It has wheels. I like that. That's a good place to start. I would agree. I need to move my drawing tablet a little bit. It is falling off of my desk. I don't want to break it because I do not own it. Okay, so I agree. We have wheels. Lovely. So that's one of the things you got. It's got an engine. So you've got your engine. In fact, the engine is an interesting one because this one even has some sub-properties, like it's been pointed out by Benjamin. So you could have like the capacity of an engine. So that's like its displacement or power or different things like that. It's got seats, doors, colors, all very good. So color and seats. Oops. And then things like doors. Lovely. So I would agree with all of that. So these are like some properties that define a car. Some of these are, well, all of them are essentially a type of data that can be different from car to car. Now, most cars, I will agree, have 4 wheels. There are some bizarre and interesting cars in the world that have less than or more than 3 wheels, or even actually just if you have one of those really heavy-duty pickup trucks, you might have 4 wheels and just your back axle, so you have 6 or something. So this is some number. So that's a number. Goodness, this is going to be an adventure today. So you have some number of those. The engine capacity could have a number as well. Things like a color, well, that's probably some textual data. So maybe it's, a string in Python or something, because that would be like red or blue or green. And these are also both numbers. So you can see that none. Let's try numbers. So you can see here that these classes things, they're a collection of properties. That's one half of them. So that's one half of the blueprint. You need your blueprint to say, or at least contain data that explains eventually how many wheels there are. But remember, this can vary per thing, so that's not fixed in here. The blueprint just says it has to have wheels, does not say how many. It has to have an engine. It does not say anything about the engine necessarily. It says it has to have a color, but not necessarily which color it has to be. So this is something that you kind of fill in. It's like a template. There's also a second half to the class side of things, and that is what it's capable of. So let's see if I can, well, we don't have a whole bunch of room there, but we'll certainly try and fit it in somewhere. So what are some things that you can do with a car? There's probably fewer things you can do with a car than parts of a car, but a couple of ideas. There's a couple of obvious ones, I'm sure. So these are more actions as opposed to properties, I guess. Hey, look at that. That's definitely the most obvious one. So you can drive a car, obviously. That's like a little function. Yep, you use it to go to places, exactly. So maybe even, let's see if I have any idea what I'm doing. There we are. There's an eraser. Oh, that's exciting. Boy, I really should have set this up better. That is, all right, so. Wonderful, there we are. So, say we have driving, and then I'll toss in one extra one because it'll be one we'll be using earlier or later today. So there's more things you could do with a car than obviously just drive and refuel it, but I will toss in refuel. Oh my goodness. Fuel as one of the options there. You'll have to forgive me. I'm an engineer/scientist, so that's not not an English major here. We struggle with basic things. So you can refuel things. You can either refuel it completely or some amount. Crash, that's a very good one. Don't worry, our programs will always be plenty capable of crashing. I'll add that one just because I find that quite humorous. Lovely. And some of these, of course, will have different parameters associated with them. So if you're driving somewhere, you might want to know, well, okay, how far? So you might want a distance in here. Or you might want, if it's a car, for example, and you're trying to go on a road trip with your friends, well, how many people are going? So how many seats do you need? People. And things like that. And there are more, of course, that you could add in there, depending on how complex you wanted to make your model of a car. So all of these things are part of the class, where it describes a blueprint for some sort of vehicle. This vehicle has some set of properties, and it's guaranteed to be capable of at least these things. So no matter which car we'll make, it'll be capable of driving, refueling, and crashing, of course. So something that now to I guess explain objects in that context. An object is a specific instance, so it's a blueprint, but with all the missing details filled in, if you will. So instead of being some, blueprint, we'll have the car itself. Here we go again with our beautiful artistry. This one's going to be a different looking car. It's also going to have, of course, a sick racing wing, because that's a very important part of cars, which is why all cars obviously have them. I can't tell if these illustrations are getting worse or better, but hey, we try. We'll put some extra wheels on the other side as well. Perspective. That's not how perspective works. Perspective works that way. That's fine. So this particular car could have 4 wheels. So your wheels would be equal to 4 in this exact case. I don't know how to color things in this program because I started using it 20 minutes ago, so we'll give it a color. We'll assume it's painted red for speed, so color red for speed. And the engine, it could be a petrol engine, this one. Petrol engine, and maybe that has an associated property. So perhaps I'll trade out capacity for one that we'll be able to use in our model today, which is fuel efficiency. So I think the United Kingdom measures that in miles per gallon, but who knows. Wonderful. And then seats for something like this. If it's a zoomy car, it might only have 2 seats. Be a 2-seater sports car and 2 doors maybe. So seats of 2 and doors of 2. So that is the primary difference between the class and the object. The object is a specific version of a more general blueprint. And of course, this is also capable of driving, this object here. But these drive functions come almost kind of directly from the class, so we'll see that later. So this capability is just kind of copied over this direction for things like driving. I think that's a good... Okay, so that's the general idea, difference between a class and an object. I know that was a bit rough, but I will do a quick poll. So I'll ask if there are any questions there before we jump on to the other thing to explain here, which is inheritance. So, poll me, or I'll just ask, how are people feeling about OO? So OO is object-orientedness, or something similar. Cool. People seem to be feeling all right. Nice. And we'll be able to see a more concrete example of this in Python very, very soon. But nice. I'm loving it. Okay, so most people seem all right with that. Now, Brooks is going to try his hardest to... Haha! Clear the screen. Well done. Look at that. Give me my PhD in screen clearing, please. Okay, so now the other thing to explain that makes this object-orientedness kind of powerful, and it fits with the real-world analogy as well. If you think about it, you can break objects down into components almost, or they have categories and then subcategories. So we could have one category, say up the very top of our hierarchy. This one is a vehicle. So what are some vehicles? Well, we could have cars. You could have a bike. You could have things like boats. All of these are boats. Options, and all of them kind of come from the overall vehicle thing. So if we think about our vehicles as being things that can drive, then all of these can kind of inherit from that, because you can also drive all of these. I guess you might say that you ride a bike, but essentially the idea is the same. You're moving from one location to another. So you have a shared drive kind of method, if you will. Oh yeah, well, I might as well introduce the terminology. So these functionalities that are associated with classes. So here, vehicle, that is a class. So it's like it's our blueprint again. Beautiful blueprint illustrations. So functions that are part of classes. So say this class has the functionality to drive. That is called a method. So it's like, I don't know, a method of doing something, maybe. So there you are. And what this inheritance does is it means that all of the properties that belong to vehicle also get sent down to the subclasses. So say you had a vehicle class that had fuel efficiency in miles per gallon, and then it also had something like a speed. Things that move usually have speeds. If you define those up here in this drive function, all of these subclasses will also get those things. They just get them for free. So this will also have itself a drive method, and it will have its, miles per gallon and its speed. And all of that is copied across all of these. So we'll do our little ditto marks or whatever. So all of these are shared because those come from this parent class up here. What you can do, though, is because obviously cars and bikes are a little bit different. So bikes, well, okay, with a rare exception, you probably have only one seat on a bike, but cars can have a variable number. So maybe you add some additional thing to your car that has that seat count we talked about earlier. So maybe seats belong to the cars. Maybe, well, I guess you can kind of give all of these a color, so you could add that to, your list of the vehicle things where you have your colors. I guess if you had... I've just realized it doesn't make much sense for a bicycle to have miles per gallon, so maybe we'll make that a motorbike. There we are. Now that analogy works again. So say motorbikes could have something associated with them. I guess some of them have windscreens, so like windscreen. Oh my goodness, screen. So that's an option. So things like that. So the idea of inheritance is then that you can define one base class that everything can borrow things from. So you put all of the shared behavior here, so you don't have to define it and duplicate it between all of these different classes. So that makes it really easy to inherit from a vehicle. You get all of this functionality up here for free. All of that comes for free. And then you can add on additional things and even redefine some things if you like. So if you want to drive a bike differently than you drive a car, you can override it as well, and we'll see that. Cool. I realize my beautiful illustrations are probably doing more harm than good, but with that being said, I like the bread loaf. Very nice, Nick. In the Discord reactions. So I'll ask, not pool, we don't want to go swimming. How are people feeling about inheritance? And don't worry, it's not the money that your family leaves you. There we are, inheritance. And if there are any confusions or questions, please do ask them, and I am happy to answer. Cool, okay, so people are feeling pretty good about that. Yeah. Awesome, and I think we'll get into all the details as we get into Python things, because honestly, the sooner I can get back to typing and away from trying to draw on this tablet, the better for all of us, I reckon. Awesome, cool. So that's the general ideas of this object-oriented programming. Let's unplug that tablet so I don't actually accidentally mess things up. Take my keyboard back, and we'll go do some Python. Okay. I think we've probably seen Spider before. I forget if I introduced it or not. As I go through this, you'll have to remind me which things we have and haven't gone over as a group, because it's been about half of a year since the last time I did one of these. So most of what we do should be new. If I do something new that I haven't explained, then definitely just let me know or ask a question, and I will help answer any questions you have. Awesome. So then, I think what we should look into first is how you define classes in Python. So yeah, here we are in Spider. Of course, you can write your code over here. We'll be running it over here, and we can use Variable Explorer and stuff to take a poke around as we do stuff. All right. Would somebody like to give me an example of a class? Just any class you can think of. Something that's in the real world would probably be the easiest to model, just because it's intuitive. Any real world classes that you'd like us to use as an example? A house. Lovely. All right. So I think that's a good idea. So you start defining classes by typing the word class. Very exciting, I know. And then we're off to the races. So you do class, you give it a name. These are usually upper camel case by default. So you'd have like house like this. Or if you had something that was 2 words, like, I don't know why soldering iron came to mind, but soldering iron would be like that, where you have 2, you uppercase each word as you go along. First letter is also uppercased. So that's the general idea of the convention there. So you'd have a class house, and just like with lots of other things in Python, you put a colon, and then a space, and an indentation. And it's that indentation that says what's inside and outside of that class. Let's first think about, so with all classes, if you want to create an object from them, it's usually helpful to define a constructor. So constructor is a special function that is used to create the object from the class. So that's taking the blueprint and putting it into the real world, if you will. That's done by a special function called init, and it has 2 underscores on either side, just like that. Def remembers how you define functions, but if you do def inside of a class, it becomes a method, which is quite nice. So init has always one special parameter, and that special parameter is something called self. So what this self parameter is referring back to this new object it's just created, and then the rest of this function kind of shapes it into form. So if you think about it, it's almost like, and we're going to try and do this with a mouse because I cannot be bothered. So if you have, this little block here or something, this is, so you have your class up at top. So class, and it gives you this generic object. So this is just an object. The way that Python actually does this is why can I write better with a mouse than I can with my actual hand? That's ridiculous. So the object, or I guess by default classes inherit from another class called object, and that gives it some basic, abilities. But for the most part, this is just like a box. It's just, a blank slate. It doesn't really have too much. Then what our init function does is it takes this basic object and as the self argument, so let's see, we have our double underscores, init, oh, that's beautiful, double underscores, and then you have self. So what the self bit actually is, and my mouse disappears when I go off the screen. So what this weird default object is, this block of marble, if you will, that needs to be chiseled, that is what goes into the self parameter. So then in here, if you did like self dot and then wheels, there's a dot there, wheels. So if you wanted to add wheels and you say, okay, this should have 4 wheels, and you can treat it just like that. What this will do is it'll take this generic object and it will go ahead and smack wheels onto it. So now that's part of the object. So now we have a block with wheels, if you will. And then throughout this constructor, you can just keep adding more of these things that modify this self blank object. And as you modify that, you can add more and more features to this. So you could, do a self doors and put some doors on it, kind of thing. That's a car door. Trust me on that, I guess. Yeah, so that's the idea of this special self parameter. And what the dot means is that this variable, the wheels variable, is specific to this one self object. So every time you look at this object, say you take this little block thing here, and you call self dot wheels, beautiful. What that will do is return, and we can represent the return, I guess, with a little arrow like that. That'll return the number 4. So it's just like a variable. You can treat it the same way. You can set it to a new value. You can do things like printing it, all of that. But this variable is specific to this block. So if you took a different, block that we say only added, well, here I am pretending there are 4 wheels on that when there are only 2. So there's a 4-wheel block. If we had a unicycle block, and you called the exact same thing, so calling the same thing, that would return instead something like 1, but you'd call it with the same name. So you would still do whatever the object is dot wheels. So self just refers to the current constructed object, and if you have a name to an object, you can also do this. So I'll show that off in the Python, make it a bit more sense. So sure, we'll do self, and we'll keep it quite simple to begin with. So I think we'll shape our little block by giving it floors. So how many floors does it have? We'll say we have a two-story house. Why not? We'll start with that by default. So I can go ahead and save this file here, press run. Now, how do you actually create one of these houses? Well, so I could say my house, this can be any variable name you want, so I'm just going to call it my house. And you can do equals, and then what you do is you give the name of the class in all uppercase. So you do house like that, and then you put brackets. Inside of these brackets is where you would put additional arguments, so we'll see those in a minute. But because ours only needs the self, and self is automatically, magically passed to this init function, we don't need to do anything else. We can just do my house is that there. You can see it pops up here. You have house object of main module. And then we could do things like take a look at how many floors my house has. So my house dot floors. So here's what I said earlier. We're looking at the floors variable that's inside of this object here, this house object. And you get 2. Now, of course, I could change that value. So I could go up and say, okay, put a new floor on my house, and that value gets updated just like that. I wonder if it lets me explore objects here. Sure does. Yeah, so here you are. You can see that looks a bit confusing. It looks like 13. It's not actually 13. It's just because the size here is 1. So the value of the floors number is, ooh, that's got a whole bunch of options. Exciting. Is 3. So that's the idea with these little variables here. Now, if you want to actually ask when you're creating the house how many floors it has, so you don't have to set it after the fact, you can do that by adding arguments to this init function. So I'll do floors. Then instead of doing self.floors equals 2 always, you can make it equal to this value floors. So self.floors, which is how many floors the house has, is equal to how many floors we're asking for. And that's from the init function. So how that works, if you go over here and go back to where we created our house, we can now say our house is continuing to grow. We now have 4 floors in our house. So now when we do that, and if we do my house and check the floor count, we're at 4 now. And that number can be anything we would like, of course. So, and you can also still change it after the fact. That is not affected by the fact you have this little argument here. A final useful thing, I'm not sure if we got around to it. I think we might have. Arguments to all functions in Python can be optional, including methods. So say if you sometimes want to specify the number of floors, but you can't be bothered all of the time, and you'd like to default to something, you can up here in this arguments bit, so where you're listing all the arguments that you want to take, like the self and the floors thing, you can put equals and then your default value. So our default value could be 2 floors, and that allows us to create our house in several different ways. So if I do house without giving it a specific number of floors, then the number that we, well, actually, I can even combine these, get rid of the variable intermediate, just do dot floors. So you can see by default we get 4 floors, or by default we get 2 floors, but if I give it a specific number, like 42 floors, we're living in a high rise now, you can see that's passed on as well. So that's how you can do little default values. Awesome. I'll do a quick check-in. How are people getting on? Any questions so far? There's a little poll. How are people getting on? Let me know if there's any confusions. I think it's not too terribly bad so far. And we should be able to pick up the pace a little bit from here, I reckon. Awesome. Cool. People doing great. Fantastic. Okay, so a couple of other interesting things. And this is more just like a good convention, but it's really helpful when you're working with lots of classes and you're trying to model things. Usually, or sometimes the names are self-descriptive, like house, for example. But if you wanted a much more arcane object, something like a round robin scheduler or something like that, that might not be immediately clear if you're not like familiar with what that is, or even if you are familiar with what that is, it might not be clear exactly how this class or object works, what type of object it models. So what you can do is add things called docstrings, and you can do this on actually all functions in Python. You do it by putting a string as the first thing after a colon, essentially, on the next line. You can do single line strings, so I'll show you that, just a normal looking string in Python. You can use either of the quotes, remember. So we'll give it the very unhelpful name of it, schedule stuff. So obviously in the real world, please make your descriptions more helpful than that. But for example, if we look here, any object by pressing Control I in front of it. Well, let's try to do that. Well, instead, okay. So I'll show you the command for doing it first. So Spider also has a built-in thing for looking at help menus, but it's also just built into Python. If you type help and in brackets put the thing you want help with, so I would like help with the round robin scheduler. Maybe scheduler. Dun, 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 dun. Did I not run this? Definitely didn't run it. Whoops, that's my bad. There we are. Okay, so what help does is prints out a whole bunch of information. You say it says help on this round robin scheduler. It tells you what module it's in. By default, it's in the main module because we haven't defined a module here. It tells me that its constructor, by default, has a number of floors, which is 2. Ignore that. That's obviously left over. It doesn't correspond to the round robin scheduler. But the important bit is that the help comes up here. So you could have your whole description here. Now, Python also has things called multi-line strings, which are done with 3 quotes. So if you do triple quotes on both sides, you can put in like whole lines. So there we are. We have something like that. This is the first line. And then you can even do spaces if you like. Here is even more help. So you can do something like that. Give that a save, give it a run, and look up our help again. And now you can see you have multiple lines of help here in your documentation. So this is the first line. Here's even more help. This is good practice to get in, especially with objects, because sometimes they can model some abstract things. So that's good to be aware of. These doc strings is what they're called, short for documentation strings. Wonderful. So we'll go back to our house example probably for a moment at least. Think about, let's see what next we want to show off. So these things here, by the way, when you do self dot and you assign a variable like this, those are called instance variables because those are stored in the dot self, and the dot self is the object. The object is an instance of this class. So that's kind of where those names come from. There's also an interesting different thing that you can do. So you can have class variables. You put those outside of any method, and you don't do dot self in front of them. So we could say here, like, have a new variable, number of houses. By default, that could be 0, of course. And each time we create a new house, we'll just add 1 to that. So we'll have number of houses plus equals 1. So each time we construct a new house, the number of houses will increase. Now, you might be wondering, how does this differ from one of these self variables? Well, that's what we will take a look at now. So, first of all, to run it, of course, what's the shortcut for that? I've forgotten. F5. Lovely. Okay, so we'll build ourselves a house. My house, I'll live in a tiny little hut. I'll have a house with a single-story house there. Oops. Not sure why that's giving me grief. One moment. Ah, of course. I'm being a bit silly. So, even when you have these things here, you still need to refer, when it's a class variable, you still need to put a .self in front of them. But the difference is that it's been defined beforehand in this class section. And that's what makes it a class variable. And we'll see how those differ in behavior in a second. So, let's try that again. There we are, we've run the code. So I'll build my house first with its 1 story. Maybe your house is a elaborate 4-story thing. And our house is in the middle of the street and has 3 floors maybe. So we can have 3 different houses like that. Each of these is a different object. So you can see if I do my house, let's see how many floors it has. Mine is 1, and your house, of course, 4, and then our house, of course, 3. So all of these are separate, and if we update one of them, so if I upgraded my house to have 42 floors, living back in a skyscraper again, then all of these for the other ones, so your house stays the same, our house stays the same, and of course, my house has been updated. But the point is that these are all separately tracked floors variables. They're all .floors, but depending on the object that comes before them, you get a different result. This differs from this class variable that we've created here, because if we do any of the houses, so your house, let's see the number of houses. So how many houses are there? Oh, it says there are 1 for that one. Oh, so is this just you getting created in the first time around? So this is not doing what I'm expecting it to do, which is a bit odd. That is all right. We can get to the bottom of that in a little while, I reckon. Intriguing. So maybe if I do the name of the class and the number of houses. Yeah, okay. So that's being a bit squirrely. Give me just a moment to try and sort that out. Here I was trying to show off the difference in class and instance variables and created 2 instance variables for you somehow. So, very intriguing. So, yeah, I'm not entirely certain why that's giving us such grief. Hopefully I'll be able to find out for you. Class and instance variables together. There we are. And you should just be able to set the location of these things. But you can't seem to be. So let's double check. Variable Python constructor. Got it. Okay. Intriguing. Okay, yeah. So the init thing, of course, is specialized to doing creating new objects as opposed to the functions necessarily. So that's a bit different. So that's okay. Let's try something new here. So let's try, instead of self, we'll try house dot. I think that's what I meant to do. Okay, now we'll need to recreate our houses. So we have my house, and this time I'll just give them all the same floors. We've already seen that they can be different. Your house, and our house. Now if we do house, number of houses. Yeah, we get 3. Okay. That is what I was going for. I apologize that I managed to mess it up the first time. So the point of the class variables is those are shared kind of between all of the different objects. Let's see if we can access it this way as well. Yeah, you can. Excellent. So if I check my house, there are 3 houses total. If I ask your house, there are 3 houses total. And if I ask our house, of course, it's still 3, because that is stored it's not an instance thing, it's not specific to the object, but it's instead specific to the class, this whole thing here. So that was a bit of my bad on this front, but that is the way that you sort that out. I wonder if I put a capital self, if that works. I might be getting mixed up with a different programming language, though, at that point. Let's give it a quick test. Yeah, okay, that's what I figured. So you do have to give a class name, I think. That is all right. So that's the difference in a class and an instance variable. Now, I managed to bungle that one up quite a bit, but I'll ask if people have any questions on that. Hopefully I'll be able to answer them now. How are people dealing out class versus instance variables? So class ones are shared. Instance variables are specific to an object. That's the main difference there. We have one person saying they're feeling positive. 2, 3, 4. It's flying upwards. Okay, cool. So that's not too bad, despite me, of course, setting that whole section on fire. All right. Moving swiftly on then. I think the last thing to then mention before going on to our example with some inheritance and stuff will be class methods. So, like we've seen with the class variables, I guess, if you will, how they're shared between everything, you can also define shared methods between everything. The point of these is that you can use them even without creating one of these objects. So say if you wanted something that printed the number of houses, the way you define a class method is using something special called a decorator in Python. So you start those with a little @ and you say class method. And what that essentially does is surrounds the code that comes after it with some extra magical Python code. Of course, it's not actually magical. You can even write your own decorators, I think. But it just does some work in the background to turn this, well, not count model, count houses. I'm thinking about the car thing already. So if you count the number of houses, that won't take any arguments, I guess. So you can say class here. What this class method does is it changes the self argument into something that stores not a reference to an individual object, but to the class as a whole. So this will essentially be equal to house, kind of, if you will. So we could say, okay, count the number of houses. That'll take this class thing. Then we could just do class dot, and then get our number of things on the road, or on a number of houses, rather. Again, thinking of the car thing already. So number of houses. And we'll do something more special with it than just returning the value. So we'll print it maybe. And then recall that we have these nice things called f-strings in Python, where you can format stuff nicely. So to remind you how those work, we could write something like there are, then you put in curly braces the bit that you want to be replaced with a value. So it'll run this as Python code here. So it'll run this Python code, it'll give us an actual number, it'll insert that in the middle of the string. So there are blank houses. And we can give that a run and create some houses. I think even if I just create the same house 3 times, because I've called this function 3 times, it should create 3 of them overall. So now if I do count, well, in fact, so you don't need to use the rhouse thing at all. You can just use the whole house class. So you can just do house and then dot count houses. And of course, it's the method. You need brackets on the end. And it will say there are 3 houses because I have created 3 of them here. So what makes that different from an instance one, of course, is I don't need to call rhouse.counthouses. I can just call the class directly, and that works just fine. Yeah. All right. Are there any questions about that? I'll probably hold off on interrogating you with a poll just yet, but I figure I'll ask if there are any questions. Cool. Crowd goes wild. All right. So in that case, oh, and yeah, okay. Before we jump into our car example, just to demonstrate how you define regular methods. Ooh, yes, the instance method. Yes, exactly. Good question. So yes, here we are. Only some very, very special methods in Python use these double underscores. Basically, these double underscores should be something that you see and you think, aha, this is doing something sneaky behind the scenes with Python itself. So here, the sneaky thing it's doing is it's being called, when you do this, house construction syntax. There's actually another one called repr, which stands for represent. So if we try and print a class normally, or object rather, oops. So over here, our house, it will give us something pretty unhelpful. So it'll just say main house at, and it gives the location in memory. That's pretty unhelpful. You can define your own representation function, and this is how Python will show that value back to you. So you could do self, of course, because it takes that, and you could say print, go back to world friends f strings, this house has, and then the number of floors, self dot floors. So we can take a look at that. Now this will change in it because it's a special, one of those special methods. If we create our house and we call our house now just to look at it, then it will return that because I'm being very, very silly. Sorry. You have to return a string when you are defining the repr function. So you do return that, not print that. That's my bad. All right, define the house and take a look at the house. Then you can see it gives us a much nicer thing than that mystery earlier. It'll actually say this house has, well, one floor. The grammar's not right there, but you know, that's a more sophisticated problem to solve. But the double underscore means it's a special function, something like one of these two, and there are more of them. Regular instance methods do not need those underscores. You can define those with whatever name you'd like. So let's see, what else can you do with a house? You can sell a house, I guess, for a price. So you have that. A price is your additional variable. Then you can say, this one we can make a print again, so it just prints out on the screen. Selling a blank floor house, and this will be the number of floors. That's kind of annoying, isn't it? Could you go away? There we are. Floors. So floor house for, and here you could put the price. So we'll give that a go. Go ahead and run it. Now if we make a house and we want to call an instance variable, we can do our house dot sell, and for what price? I don't know. Maybe a tiny 100 quid flat. They are easy. So, or whole house even. So you can get something like that. So you don't need special names there. And just to show again that these instance methods are different, you can't call these instance things on the house directly. It wouldn't make sense to sell the idea of a house unless you're like, I don't know, trying to convince people to live in houses in the first place. So you see here that it complains about missing an argument. Price. So for things like this, there's a sneaky second way to call these methods. Yeah, I'll show that off real quick. So our house dot sell is exactly the same as house, our house, comma, then the price. Those are the same, but obviously that's the simpler and vastly preferred method. But you can see though that since it's not a class method, this is an instance method, which is the default. You can't just call it normally here with the normal number of arguments. You also need to add the specific object that you would like to sell. Cool. Does that help answer that question? In a class method rather than class, you could use class. Yes, I think so. I'm pretty sure. In fact, I'm certain all of these initial names here are entirely arbitrary. Self is just a bit of a it's strongly conventional. You'll see self almost everywhere. People might get angry at you if you don't use self. I think it'll still work. So we could do something like, well, actually, no, there is a reason you can't use class in particular. The reason you can't use class in particular is because that's a reserved keyword in Python. You could name it something else like this class. I think that should be fine. So we can try that. Class. And that should be a-okay. The only reason that you would use something like CLS is, again, because that's like the convention. And other people will instantly know what you mean if you do that, as opposed to this, which they might have to think about for a moment or a bit longer. So let's see. House, let's create some number of houses. That's 5 of them. And then we should be able to do just the same, house, count houses. Oops. That's certainly not what I wanted to do. Count houses. Yeah, and that'll work just fine. So these names, they can be changed. Convention dictates that CLS and self are the ones to use when possible. But you are free to do as you please with them. Awesome. Any more questions? And does that answer both the questions you've asked, Ben? Awesome. Cool. Excellent questions. It's very good when people have questions, because that means people are listening, which is always reassuring when you can't see anyone. Awesome. I think that's a basic idea here. So let's jump into our little challenge, which will be, and I'll show you how to do inheritance once we come to that bridge soonish. So let's start with our first challenge. I will paste it in from the specification that I wrote up of it. So the vehicle class. We'll create a new, yeah, okay, we'll do this in a couple of ways. So I'll put it here as a file of its own, and I'll probably actually want to say that as something different. I can put that just in my downloads, which is a world of chaos. World of chaos, because it doesn't need to be anything except a txt, so it just gets rid of the highlighting. There we are. Okay. So, that's a bit not fitting on the screen as well, but that's all right. We can work with it. As an alternative, or supplement rather, I'll also put it in the Discord. So in the Discord there is our goal. We want to define a vehicle class. So it says our first instruction is define a class called vehicle. Then we're going to need to make a constructor. This constructor will take a model name, a fuel capacity, a speed, and optionally miles per gallon, so a fuel efficiency, although this should default to the value 30. So let's start with just those first 2 instructions. If we want to define a class called vehicle and then create a constructor that takes those things, what shall we type? Feel free to drop suggestions in either Discord or Google Meet. What do we start with when we're defining a class named vehicle? Also, it doesn't have to be like perfect, right? Hey, there we are. I agree with Philip. The only modification I would make is lowercase the word class, because I think since the keyword, again, the casing is important. Yeah, so it won't recognize it if it's uppercase. So class lowercase, and then we have vehicle. Lovely. I would agree. There's our vehicle class. Quite sophisticated, I know. Cool. And now what we need to do is define a constructor that takes looks like, well, let's see, 1, 2, 3, 4 arguments, which are model name, fuel capacity, speed, and MPG. How are we going to do that once we've defined our class? What's our next line look like? And you can always give like partial things. It doesn't have to be full lines of code every time. Wonderful. Hey, that's a very good template there, Ben. I would agree. So we want to do def init. That's our special named function with its double underscores. And self, you want for all constructors if you're going to have instance variables, which you almost always will. and then however many arguments over here. So actually, I think that syntax here, args, does its real Python syntax as well, not just an example. This can hold a list of several arguments, and it puts them just in a list instead of giving them specific names individually. In our case, though, we can give them the individual names. So we can do the model. Next one might have been fuel capacity. Yep, fuel capacity, speed, and MPG. So fuel capacity, the fuel cap, speed, and then our MPG. How do we give this MPG a default value? How do we default it to 30 and make it an optional argument so we don't have to type it every time? What should we put after our MPG, or how should we make it give it a default? Any ideas? I would agree. Yes, so you can do equal sign, and then whatever you want the default value to be. In this case, 30. Fantastic. Of course, don't forget your little colon after every method and class thing. And then on the next line, we can start setting things. So you can see in our instructions, we have, as a little sub-step here, you want to set the model, the fuel capacity, the speed, the MPG, the fuel, and the odometer instance variables. So that's a whole bunch of instance variables. In fact, I'm going to copy those onto my clipboard so I don't forget them when I switch over to the other file. And then we have, so seeing as we have two additional things here, we have the fuel parameter and the odometer. We need to know what they're initially at. So fuel should initially equal the fuel capacity. And then the odometer, so we're starting with a full tank. And our odometer should start at 0, so it's a new car. Never been driven. How fun. Cool. So there we are. That's our disaster we want. Well, actually, we just need fuel and odometer in addition to the ones we already have. So unfortunately, this chunk of code is slightly repetitive. I've not been able to find a nicer way to do this. Some languages have nice ways to do this when these parameter names are the same as the names that you want in the object. But in Python, you usually just have to go through for each of the arguments you want to store as an instance variable. You can do self model equals model, and then duplicate that pattern for all of the other things as well as we go. So we can have our fuel capacity is equal to the fuel capacity, and on the next one, our speed is equal to the speed, and the miles per gallon is equal to 30. The fuel, which is one of our new ones itself, I'm struggling with the word fuel today, starts at the fuel capacity, so it starts at a full tank, so we can say that also starts at fuel capacity. And of course our odometer starts at 0 for our lovely shiny new car, just like that. And obviously, since this is a function and you can do whatever you'd like in here, we could do much more sophisticated logic. So say if you want to start at half your fuel capacity each time, you know, all Python code is valid here. You can put in loops, if statements, whatever you please. So not all of your parameters have to become an instance variable. That just happens to be the case currently. Lovely. So that looks not too bad. And yeah, okay, we'll blast on to the next bit so we don't waste too much time thinking about that. Say if we wanted to write some documentation for a vehicle, if we want to write some help information for a vehicle, where and how should we do that? So how would we add something that says, I don't know, here's one I prepared earlier. Whoops. If we wanted to put this string or this bit of help text somewhere, how do we put that so it appears whenever we're trying to get help for the vehicle? Any ideas where that might go?
Doc strings.
Hey, I would agree. Lovely. Yeah, so as Kate's pointed out, we probably want to put that in a doc string.
I just don't like it when people are quiet for too long.
Very helpful, I think. Lovely. So in that case, we can hop up here, and the doc strings go right after the class itself. And you can put it here in triple or single quotes since it's just one line. Triple quotes are conventional, so I'll do those. In fact, even these, when you use speech marks, that's probably more conventional to do that. And those are both equivalent. With triples, they're still multi-line strings. Let me just paste it there. And in fact, I will probably split that onto several lines because it flows off of the screen. I also missed the E at the end of distance there. So there we are. Represents a vehicle that consumes fuel to travel some distance. So there we are. Now we can give that a quick test. And go ahead and build our... Well, let's get some help on our vehicle, actually. So we can test that that's worked. If we get help for our vehicle, you can see a whole bunch of information, but importantly, we have represents a vehicle that consumes fuel to travel some distance. And you even have the information in our constructor here, how to build it. And it even tells us our default MPG is 30, which is very, very helpful. And you can see it automatically gets rid of the self thing, because when you're building it with this syntax, where you give the name of the class first, the self is unnecessary. It's automatically passed to the init. In fact, it's actually always the case, I think, with the init itself. Cool. Lovely. So that is our place to start. Now, we need to add some functionality to our vehicle, I guess. So let's see what our next instruction here is. So our next one is to implement a drive distance method. So we want to drive some distance, which will be an argument that we give it. Yep, where it's some distance in miles. So the miles, I guess, is relevant for the sake of the fuel capacity tracking. And that can be broken down into a whole bunch of different steps. So we'll start by defining our instance method. So, or I guess you just call those regular methods usually. We can start, call it drive. Then, anyone real quickly, what parameters do we need here if we want it to take the distance, but it's also a method? What parameters do we want to put in here? Fantastic, I would agree. Self and distance. I would totally agree with that. Fantastic, so self is always the one that comes first. The order of these is important. If you swapped these around, then distance, you'd have to do, well, distance would become self, self would become distance. So the object is always passed as the first argument for these methods. So there we are, that's lovely. And then once we are driving some distance, what else? Well, what calculations do we need to do? So first thing to do, I guess, is to check if the fuel left in self.fuel is enough to drive this distance. So that's the first thing to do, I suppose, is figure out if we can make the trip. So for that, we'll want an if statement, and I'll first show off something simple that we've seen before, and then also show you a cool way to make it even more modern Python. Well, it's a bit of a controversial modern Python thing. Some people, notably the creator of Python, was very against this operator's existence, but I think the creator of Python is being close-minded about the Walrus Operator, which we'll see in a moment. So first thing we want to do is calculate how much fuel a journey will take. So fuel used, in our case, this calculation is pretty simple because we know the distance that we would like to travel. So we're taking the distance, and we can divide that by the fuel efficiency of miles per gallon. So if you think about the way that that'll end up working, you'll just end up getting gallons out of that calculation, so miles per gallon. Because if you go 1 mile, if you go 30 miles rather, and you divide it by 30, you'll be using 1 gallon, which is what we're looking for. So there we are, there's our calculation for that. Except MPG here, that's not actually a defined variable because it's part of the instance, so we need to do self.mpg to get that. Excellent. And then we can just say if the fuel was enough or not. So we could say if the fuel being used is less than or equal to the amount of fuel we have left, which is in self-fuel, then we're good to go. So we can print just a placeholder message, driving. And the alternative could be, and in my design I've actually had these returning things. Does it say to return these specifically? Yeah, I'll return the model of the vehicle in the distance interval. So yeah, so we'll save on the print and we'll just do a return instead. Good thing to keep in mind about returns, especially when you're working around if statements. The second this line gets hit, it leaves this function. It won't run anything below it in this function. So that means this is actually a case where we don't need an else statement. The else here is unneeded. We can just do instead return and then do something like not enough. Wait a minute. You did it. Yep, that's fine. Not enough fuel. And one of those two will be returned, but never both. Cool, we'll give that a quick test. So spin things up. We'll create a vehicle. It'll be a car to start off with. We can do vehicle model. Does anyone have a favorite model of car? Go for it. First one to be the favorite model is the one we'll use in our examples. There we are. Sure, we got Fords. You know, I like that suggestion because it's a very short, easy to spell name. It's much better than if you asked me to spell Lamborghini or something, or Bugatti or Bugatti. See, I can't even pronounce that one. Ford, very affordable. I like that. Cool. Fuel capacity. Say that has a pretty big tank on it. I actually don't really know what standardized tank sizes are, so we'll go with 10-gallon tank. Speed. Maybe it's a big truck. I'm sorry, you don't type the word speed. So maybe it's a big truck. Maybe you're only moving about 60 most of the time. And miles per gallon, we'll leave it default. Awesome. So that's all we need there. Now note, obviously, there are 5 things that we've defined here in our initializing function, but because self is never something we need to pass, and because miles per gallon has a default, we only really need to supply these inner 3. So we supplied our 3 here. So there we are. We have our car there. Of course, remember, you can't view it directly terribly easily. There are ways to explore it, though. We can, of course, do car.model to check which model it is. We can see it's a Ford. We can see how far it's driven. So our lovely new car has never been driven. Our odometer's at 0. In fact, that won't even be updated yet. But what we can try and do is drive our car. So, well, let's think about this for a second. If we have a 10-gallon tank and we have 30 miles per gallon, since that's the default thing, we can actually check that. Of course, it is the default, so we know that's what it'll be. But for our own sanity, there we are. The miles per gallon is 30. That means we should be able to drive 300 miles on one tank of gas, or, ooh, that was my American coming out. Sorry about that. One tank of petrol, or diesel, actually. Could be either. So we'll be able to go 300 miles, so let's try 2 different drives, since we're not actually doing any calculation here yet. If we do car, not cat, car, drive, and some distance that is drivable, like 100 miles, going on a long road trip, but nothing crazy, it'll say driving. And of course, if you do something that's undrivable, like 400, you won't have enough fuel. Now, there is a way to combine these 2 lines into one, which is kind of exciting. So, and it's a new thing at least, so worth looking at, I guess. It's the Walrus Operator. So by default, when you run something like this fuel used, you can see, well, name distance not defined. Of course it's not defined, because I've just copied that totally out of context. So let's just do 4 divided by 2. Wow, what sophisticated maths. You can see it doesn't return anything. There's no out value. It's set the fuel used variable, so we can check that, and that's fine. It's equal to 2, like we expect, but it hasn't returned this output for us. The alternative is this Walrus Operator, which means it looks like a walrus because the idea is this: the eyes, there it's walrus tusks, how cute. What this does is this both sets this variable and returns its value at the same time. So you can, I think it always needs to be in brackets, actually. That was the compromise that they made. So yeah, if you put it in brackets like that, then you can get the output of 2. So that's kind of interesting. Let's actually change the number that this is. So let's change that to 7. So fuel used is 7. So you see we both get a return 7. And also at the same time, in one operation, the fuel used has also been updated to equal 7. So it's a nice little way of combining these 2 things into one. And it's kind of a neat little thing. So what you can do, make it a Walrus Operator there. And you can just grab it from, oops, don't do that. I'm using the wrong key bindings again because I'm not used to working in Spider. And we can just plop it in here. And the last thing we'll need to do is put it in brackets because that is something mandated by the Walrus Operator. So there we are. This does the exact same thing as before, but squishes down our lines into one and prevents us from needing to do them separately. Although it's a matter of taste really often. So the separate line might be your preferred style, in which case that's totally fine. But this is just to show that off and teach something new. Cool. Okay, so what else does our drive function need to do? Our drive function has a whole bunch of purposes here. So first of all, it checks if the fuel is a tolerable amount, and if it is, it will decrease the amount of fuel in the tank by the amount you used. So that makes sense. We're actually going to consume fuel when we drive now. And increment self.odometer, so you can keep track of how far you've driven. So let's do that first. So that's pretty typical. Instead of our little if statement here, we can do something easy enough. So we'll do self.fuel. And minus equals, remember, subtracts and updates the variable at the same time. And we want to subtract the fuel, every time, fuel used. Lovely, so there we are. We're actually consuming fuel when we're driving now, and we can update our odometer by adding to it. So again, plus equals here, the distance that we've driven. So that's cool, and that can also return still the driving that we had earlier. Driving. Lovely. Cool, we'll give that a run. Go ahead and take a look at our car. Define our Ford again. There's our car. Let's drive it. If we drive it 100 miles, then it will drive just fine. We can check how full the tank is by doing car.fuel, and you can see it's a bit of a cursed fuel amount, but oh well. We've made it through 1/3 of our fuel, it looks like, and because we started at 10. So we've made it through 1/3 of our fuel, and we can also see how far we've driven. So odometer, 100 miles so far. And if we call this again with some different amount, like say 30, and then add on to that 40, then it keeps track of all of this as we go along. Our fuel has decreased again, and our odometer is now up to 170. So that seems to be all working pretty well so far. So this is a nice example of kind of how object-oriented programming works a lot of the time, is your object has methods, so you can ask it, you can command it to do different things, and it'll update a whole bunch of things in the background for you. So when you want the car to drive as the user, you don't need to say, okay, I want to take my car and subtract from the fuel and all of this stuff, and you don't have to do all of that manually. Instead, since it's in the method, and you know that the method applies to the object in front of it, the car tracks all of this state internally, almost. So it's a combination of the data, which is stored inside the car, with these functionalities from the methods. Excellent. I think there was one last step of this, mostly. Yeah, so return the model of the vehicle with the distance driven and the number of minutes that it took if it was traveling at self.speed. So we also have a time calculation to make here. And if there's not enough fuel for the journey, return an error message with the model of the vehicle. So what we can do is just change these to some F strings and toss some data into them. So we can say, for example, and then here, self.model. So we want to know what model it is. So this would say like the Ford or the whatever. Drove. And then the distance. We have here, distance. Miles in, and then we could get the time here. Let's calculate that as a separate variable. You can put full expressions inside of here, but this one's a bit of a longer calculation and probably isn't nice to have in the middle of all of that. So if you do minutes that it was driving, you'll get distance divided by the speed. So that will tell you how many hours it took to go that distance, because speed is in miles per hour here, we're assuming. And then after that, you want to multiply to get minutes by 60. So drove that many miles in this many minutes. So minutes, and I think I might be thinking of the wrong programming language again here, so you'll have to give me slack if this is total rubbish. Let's see if this works. There's our vehicle. Oh, I forgot. I need to reload the file. Empty f-string expression not allowed. I will assume then that it doesn't like this. I'll try putting the equal sign at the end, just in case that's what I was looking for, actually. Oh, and even then, I don't think this is going to give me exactly what I'm looking for, is it? Okay, so that'll work at least. Now if I do drive, well, car.drive. So this is a neat little feature of f-strings. It's good for like debugging. I don't think it'll actually be good for this particular purpose, but if you do car drive, 10 miles, speed is not defined. Oh, of course, sorry, that's my bad. Should be self.speed because that's an instance thing. Lovely. Okay, repeat that testing process real quickly. Vehicle drive. Yeah, so if you put this special little expression here in a format string, we have just the name of the variable, then an equal sign after it. It will print that. It'll print the name of the variable and the equal sign, but it will also print after it the value itself, which is kind of nice for debugging sometimes. There are better ways to debug, strictly speaking, but this can be helpful. In our case, though, we just want to go back to minutes. And note that this is, in contrast to, normally it doesn't print the word that is in here, the variable name. It just prints the value. So if we get rid of the equal sign at the very end there, and try the same operation, then you can see it just gives the number. And we have to add minutes to the end on our own, like that. Cool. Okay, so if we go ahead and run that, car, vehicle, and car.drive. So the Ford drove 10 miles in 10 minutes, and the reason that's the case is because the speed of our car is 60 miles per hour, which means 1 mile a minute. So that checks out. If we gave our car a bit of an upgrade, toss in a turbo or a supercharger or something, I mean, you probably have more than 80 miles an hour, but say the car got a bit faster, then you can see the time calculation obviously changes there to be less time, because now the thing is moving faster. Cool. That is that, and then all we need to do is change our error message so that we get something proper. Oh, and we can check with all this driving that we've been doing there, how much fuel we have left. So fuel, we have less than we started with, obviously, and if we do something that we can't drive, that we can't make, like 1,000 miles, it'll tell us not enough fuel still. We'll just upgrade this message to be a little bit more helpful. So it'll say the, and it will get, again, the model of the car, which we can put in with our f string there. So the model didn't have enough fuel for the journey. Beautiful. Cool, that'll do. And we'll give that a quick run. Oops, that was 5, not F5. Vehicle, and we'll drive it 1,000 miles. And it says, now the Ford did not have enough fuel for the journey. Lovely, so it even remembers what it is. And of course, if we define a second car that is not a Ford, so this could be a Nissan or whatever, this will be other car, then this works in exactly the same way. So Ford didn't have enough. If we do the other car, the Nissan didn't have enough fuel for the journey. So it keeps track of which one it is. Excellent. Okay, that's all for the drive method, I think. Are there any questions so far about that? How are people feeling about the driving method, and everything we've done so far? I'll do a poll. Poll. I always type pool. How are people getting along? I swear every day I get slower at typing, worse at spelling. We're just constantly sliding downhill. That's life, isn't it? Probably peaked 4 years ago. Who knows? Awesome. Okay. People seem to be getting along all right overall. We've got at least 3 people. Oh, there we are. Pouring in. Wonderful. Cool. All right, so we'll continue on with our challenge of defining a car. So the other thing I think we have to do is give it a refuel method so that we can refuel things when we run out of fuel. So say our other car, if we drive it a decent distance that it can do, like 100 miles, and do it again, and do it again, eventually it runs out of the fuel to do so, as we can see there. So it didn't have enough fuel for the journey. And it will continue to not have enough fuel because if we check our fuel, it'll probably actually be something a bit quirky here. Other car fuel. Yeah. So that's a bit squirrely. I'm sure you can see how bizarre that is. So it's 3.3 repeating almost. But here's one of the beautiful horrors of working with what are called floating point numbers on computers, is that they're limited in accuracy, because in the real world, decimal numbers, real numbers, there's an infinite number of them. Your computer, however, does not have an infinite amount of space. So most programming languages have to round these things a little bit. So here you can see, even though really we should be able to go 300 miles, we can't quite do that because we've lost some precision here at the end. So what should be 3.3 repeating out until infinity has been rounded down to 3.2 here. Well, 3.26, so I guess it still rounds to the same. But the point is this is less than a third because it's lost some accuracy as the computer's been working with it. So that's something to be aware of in general when you're working with computers. That happens with almost all programming languages, although there are ways around that. But if we try and drive, say, slightly less of a distance, 99 miles, then of course that'll work, and it'll make 99 miles in 99 minutes and leave us with a very tiny amount of fuel. We could manually refuel this ourselves, by doing fuel equals whatever. So we could say 5,000 gallons even. And then our car can drive around the whole planet. But obviously, that's not realistic, is it? To drive, 10,000 miles on one tank of fuel. So what we need to do is add a method, essentially, that does this a bit more intelligently, respects the fuel capacity of the car, and doesn't force the user to manually refuel with an equal sign, which is obviously prone to errors and things that are impossible and shouldn't happen. So to do that, we'll just define our second method. So just like our first one, def refuel, we'll just assume that we're going up to the maximum fuel capacity allowed by the car, so I don't think there are any arguments for that one. Then what we can do here is calculate how much you need to refuel by. This is so we can print a message that gives us that information. So the needed fuel amount is self, and the fuel capacity, well, almost right there, the fuel capacity minus the current amount of fuel. So there we are. And that's how much is needed. What we can do then is add that to our fuel. So add what was needed. An alternative, identical way to write this line of code would be self.fuel equals self.fuel capacity. So same idea. And then finally we want to return a string saying what we've done. So here we will do refueled and we'll again say what we are refueling, so the model of the car, or vehicle rather. Could be any vehicle with needed gallons, because that is our unit. So if we save that, go ahead and run it, take our car, our vehicle, our Nissan here, and take our other car and drive it. We'll drive it really far as I can go. 300 in one big swoop should be doable. Yep, drove 300 miles in 300 minutes. So the fuel should be totally empty on this thing, I think. We can check other car dot fuel. Yep, fuel tank's totally empty. So now if we do other car dot refuel. Whoops, sorry, that's a method. You have to put brackets after that, like that, and then press enter. It says refueled the Nissan with 10 gallons. So there's the amount. Now say if we half depleted our car, or maybe 2/3 depleted it, so we drove 200 miles instead and did this again, you can see that we've refilled it with 2/3. Now also, you would be correct in saying, wow, that's a really ugly way to show a number. There's like, well, an obscene number of decimal points there. So luckily, F strings, back at it again with all the convenient features, you can essentially specify the number of decimal places to print floating point numbers to. So after our needed value here, which remember is our floating point number that tells us how much fuel we're adding, you put a colon, and you can give some options after this. So I want to do decimal place accuracy, so you put a decimal thing, and then I want 1 decimal place for the floating points. So this syntax here is something that you can find more information on in the documentation of F strings. I think there's a whole bunch of squirrely things you can do with them. But what you need to know for at least this context is that it will make that look much nicer. So if we take a look at it, and it just kind of rounds it to the nearest 10th place currently. So give it a run, and go back and create our Nissan, and drive it 200 miles, and then refuel the car. Now you can see it rounds this nasty 6.66666 repeating down to just 6.7 when it displays it. But note very importantly that since this is just when it's displaying it, it doesn't actually change the amount of fuel. So it's not going to cause an even greater loss in accuracy. If you do check the fuel level manually, you'll still get, well, okay, very funny example, Brooks. You just refueled it, and of course it's going to be at 10. You'll still get repeating numbers here. It's not going to actually round the real number. Lovely. Cool. I think that's actually all we need to do for the refuel thing as well. So we're flying along here. Any questions about what we've done so far? I'll copy and paste our last poll. See how people are doing. How are people getting along? Again. Any questions? Feel free to ask. And if not, we'll fly on to our last couple parts of the challenge. Cool. Okay, well, at least 2 people are surviving. Oh, numbers are climbing again. Seems like whenever I call people out, they go and click it. I appreciate it. Okay. Awesome, yeah, if you do have any questions, feel free to type them in either place, and I will pay attention to them eventually. I promise. Okay, so that is our first task. The second task I had is to expand what we've written already, but this time give it a class method. So I will copy my specification that I have here, and there we are. So we want to extend the vehicle class with some class methods. So we want to add a class variable that's shared by all of these instances called on the road. So this will keep a list of things on the road. So set it equal to an empty list initially. And then every time a new vehicle is constructed, it should append self to this list. So it takes the car itself and puts it into this list. So you can have a list of all the cars on the road. And then this is actually a somewhat common pattern. You might find that in different places where class variables are used to track all of the objects in the class. Awesome. Then the last thing we'll need to do is define a function that's called count models, and that'll take a name of the model, and it will look for how many of those models are on the road. So it'll go through all the things on the road and check through all of them. Whoopsie. Messed that up. There we are. Cool. So to make that a little bit more concrete, well, yeah, okay. So we'll start with a question. Well, I'll go back to interrogating you all. I know how much you all love being harassed. So, on that note, where should we put a class variable? This is the one that I bungled up earlier, but at least I put it in the right place the first time. So this is for the class. It's not for the instance. Where should we put our on the road variable in this code? Oops. Under docstring. I think that's a great idea. So the docstring needs to be first, but we also want it under the docstring because that's before and outside of all of our methods. So we can do on the road, and we can set that equal to an empty list like we were asked to do. Wonderful. So that's a great start. And then what we can do is add things to this each time. Oh, that's very interesting. I've just understood retroactively why my car example worked when I did self-dot and why it didn't when we did the house example. If people are curious still at the end, I'll explain it. It's a bit of a weird thing to do, I think, with deep and shallow copies, which is something we'll learn about at some point, I'm sure, but probably don't need to at the immediate moment. So, okay, we want to take the vehicle, the class itself, and we want to take the on the road and append to this list. Remember, that's how you add something to the end of a list. We want to put this whole object in it. So this whole car, after we've set it up, slap that on the road. So after it's been initialized, we're building the car here, and we're shipping the car out into the real world. Lovely. So if we give this a go, we can see some basic stuff here. So if I go ahead and build do I have reverse search here? Of course I don't, it's spider. So if we build a Nissan, and we build a Ford, and we build a Honda. There we are, getting, well, okay, I've done Japan twice, I think. Oh, well. So there we are, but have something like that, and then we can take a look at our on the road variable. So remember, we do v, well, it can actually be any of those things, but since I didn't save any of those in variables, we'll do vehicle on the road. And we can get our list, and you can see there are 3 items in the list. How wonderful. If we were to map through those, or loop through those, so for vehicle in the list of the vehicles on the road, let's print the vehicle's model. So there you are. Then it'll print out all the models of them. So that's just a little loop, Nissan, Ford, and Honda. Cool. So that'll actually help us with our final little function to define here, which is implementing a class method called countModels that takes a name and looks for how many of those are on the road with that particular name. So does anyone remember the little decorator thing that we need to put above class methods? Anyone remember what belongs on this line here that's highlighted? I won't wait too long for this one in case you don't remember. But well, yeah, that's definitely a good place to start. I would agree with that. Do you remember this thing that we put after the @ signs? Hey, fantastic! Look at that. Beautiful. At class method. You're right. I think it's just class method singular, but yes, very, very well done. Awesome. Here we'll call this new method count models. We'll take the class. I'm abbreviating it with the standard one. Remember, that can be whatever you'd like. And then model. There we are. And that's the model we're looking for on the road. Oh, I don't know why Spider has to be like that. Okay. Awesome. So now what we'll do, the count. There are a lot of ways to do this. And I'm going to do it a fancy way, because I think we actually went over list comprehensions at some point. Do people remember list comprehensions? Did we go over that briefly in the review session last time around? If not, this might be a bit of a crash course, but I'm sure it'll be great. Cool. Does anyone remember what list comprehensions are in the chat? Yes or no? Feeling like that might be helpful to know, I guess. Yep, okay, that's good at least. Is that the right language? The answer is no.
I don't think so.
Is it length then? Or is it a function length?
What?
Is it len like that? Ah, okay, good shout. Well, in case anyone wants to program in Rust, that's how you do it in Rust. Not in Python. Thanks for their help there. It's always one of those 3. And I think JavaScript is an even different one. Anyways, cool. So for list comprehensions, let's see if I remember this. So it doesn't really matter what our model is. We'll just say vehicle, I guess. So V for vehicle. For the vehicle in the list of vehicles, so that will be the class and then on the road list. And then we want to look if the vehicle model is equal to this model here. So that is a bit of a crazy statement. If you remember list comprehensions, and there's like a 20% chance this is right, at least. What this will do is generate a list. Well, actually, I'll show you the whole list first before I calculate the length of it. So if I do this and run this and go ahead and do my thing where we put some stuff on the road, we'll just put a bunch of Fords there and then one Nissan at the end. So do that, and then we can do vehicle count models, and I could say, oh, actually, yeah, so we'll see how this works. So you do have to give it a thing. So if I give it a Nissan here, then you can see it returns me, or returns one option for me. If I count all of the Fords, it will return 3 options for me. And if you match up these memory addresses, they match up to these, I promise, but it's not the most easy thing to do by eye, but that's okay because we don't actually want to know the individual cars, we just want to know how many of them are. So therefore, by getting the length of this list, you can figure out how many Fords are on the road or how many Nissans are on the road. So the length of this, 1 Nissan on the road. Length of this, 3 Fords on the road. So that's what our len here is all about. Lovely. Cool. I think there's our nice, super fancy count models thing. Are there questions about list comprehensions? Because that might be new if you missed like the review session or haven't done too much Python before. Just double checking that this actually works. Yep, this on for 3. And I put no Fords in this time, so it should be 0. Cool. Okay. I'll create a poll about how are things going. And you can let me know. And there's one last little bit that we can get to, which is inheritance. And definitely feel free to ask questions about particularly this line if it's alien to you. Because that is just a shortcut. Well, okay. Yeah, okay, so that's a shortcut for writing. The other way of doing that would be for the in class on the road in a for loop. And then you'd have a second if statement inside of here. And actually, since we're building up a list of these things, well, we're kind of counting them, aren't we? So that would be the same as starting with a count of 0, going up the list, checking if the model is correct. So the vehicle model, if that's the model we're looking for, and if it is the model we're looking for, then we would want to make the count go up by 1, something like that. So all of this code, well, okay. All of this code is equivalent to this one line here. Yeah, so what's that mean? Exactly, that's a good question. So maybe this closes it up a little bit. Things that come after the if are tests. So double equals is either a true or a false kind of thing. So, you know, if your model is a Ford, then model double equals Nissan will be false, but is it a Ford? Then you get true. So this is basically saying if it's true that this model matches, then add it to the number that we're counting. Or in this case, if this model matches, then include it in this list of vehicles. So the reason I said use that one is just because it's much shorter than these 5 lines. But again, it's a matter of style. This is probably more functional. I think Python nicked list comprehensions from Haskell, which is one of my other favorite languages, which is a very different way of working. But yeah, these are equivalent things. Awesome. Any more questions about that? Does it make sense how these two things are equivalent? The highlighted bit and then this first line, those are the same thing? Or do the same thing in the end, at least? Cool. I will assume it is all right in the absence of further questions. Did I answer your question, Mohammed, about the double equals sign? Does that make sense? Awesome. Fantastic. Cool. All right. In that case, I think we'll have just enough time to go through our final thing, which is a bit of inheritance. So we haven't actually seen how to do that in Python yet, so I'd like to learn that real quick. So there's our count models thing. Lovely. So the final section of our challenge is, I'll copy it over. Oops, there we are. Implement a car class that inherits from vehicle. Define a constructor that takes all of the same arguments as the vehicle, but add some more defaults. So default fuel capacity to 10, default the speed to 60, and add a seats argument. And then we're going to store the number of seats. So basically what makes this different from a regular vehicle is it has some new defaults and it will have extra seats. So we'll go through that real quick, and I will show you how to inherit from a class. So class, car. And if you want to inherit from something, so remember when we had my utterly hideous inheritance diagrams here, where the vehicle is the blueprint for all of these things below hand, so they borrow its properties. You put that in brackets. So we would put vehicle here. So this will create a car that also takes all of the things from vehicle as well. So if we do this, and then we want to add a constructor that takes a certain number of defaults. So again, for constructors, def init, and we'll do self as the first argument. And then we said all the same as these, but plus seats as well. So I'll put seats, wrong keyboard command there. But we'll put seats right after model probably. So I'll put model seats and then paste that in. Lovely. But we said there were some defaults. So the default fuel capacity was going to be 10 and the default speed was going to be 60. So that's just what we were specified to do. So now we have this lovely constructor here. Now, you may be wondering, do we have to go through really and set self.fuel equals fuel again and repeat all of that stuff that we did before? But the answer, luckily in this case, is not actually. So even though you have to do this kind of repetitive code the first time, if you're inheriting from something, you can call this function here. So from the car function, from the car constructor, I can call the vehicle constructor, and I'll show you how to do that. So if I go ahead and, well, first we'll set our number of seats. Yeah, we'll set that first. So our number of seats, that is a new one, so we'll have to set that ourselves. Not self, sorry, seats. So our number of seats equals the number of seats. And now to call the other constructor, you can get this class, if you will, using the super function. So what this does is this will return essentially vehicle. So you don't have to use the name vehicle here. So you could do, just to be clear, vehicle dot and then underscore init and a double underscore like that. That would be fine. You could define your thing like that. However, the super thing, if you changed what this is inheriting from, so maybe this car inherits from four-wheeled vehicle, then this would automatically work. You wouldn't need to change this in the second place. Nice. Cool. So there we are. A car is a vehicle. Super. So this means we're going to call the init function that belongs to vehicle. So to that, this time since we are calling it this init way, we need to actually pass it the self parameter. But we can do that because we have our own self parameter from this init thing. So we can pass in self. Then we just need to do the same order as the rest of them. So self, model, the fuel capacity. Remember, the vehicles don't have any idea what seats are, even though they probably should, but maybe there are standing vehicles. Yeah, say segways. Those don't really have seats. So we're being inclusive here. Lovely. Cool. So that will call this init function up here. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So that's all correct. And that is actually our whole initialization function. So this one saves us a lot of time by calling the one from its parent class. That's also sometimes you'll hear that if something inherits from something else. The vehicle here is the parent. Car would be the child class. So think like family trees. Lovely. Then our one last thing is to define a drive function for it. So we can see, yeah, the rest of the instance thing should be set by calling the parent constructor, which is what we did with our super init thing here. Super init. Lovely. So now what we want to do is override the drive distance method to become drive distance with people as well. So something interesting about this inheritance is, and we'll see this actually in a second, it gets these methods for free. So this car, actually right now, if we just ran this code, which we will do, so we'll build ourselves a car. It's going to be a car. Car requires only the model name now, so a Nissan and a number of seats. So say a 4-seated Nissan. Doot. Have I done something silly? It takes a certain number. From 4 to 5, but 6 were given. Is that my fault down here? Oh, yeah. Sorry. I'm being silly. You don't need to put self here, of course, because you're doing super dot. So the self comes from the super. That's me being very silly. Sorry about that. There you are. So you don't need the self there, you just need the other arguments. So just as if you were regularly creating it. So that then is identical to just calling, not quite identical, but kind of identical to calling vehicle and then the model thing like that, all throughout. So we are, give this a go. Okay, cool, there's our car. Now you can see this car, even though we've not defined a drive or a refuel or anything, because it's inheriting from vehicle, we can already drive it. So we can already drive our Nissan, 30 miles, and it's fine. Nissan drove 30 miles in 30 minutes. So it's working exactly as expected. And this, of course, also can be refueled, because that's being shared as well. So there we are, refueled with 1 gallon. But what you can do when you're inheriting things is you can give a method with the exact same name, and you can replace the first one, kind of. So here we're going to define a new driving function. This one is going to, as this says here, take into account the number of people. If it's greater than the number of seats, there'll be an error message. So if you can't fit all the people in the car at the same time. So distance, and I'm aware of the time kind of running a bit close, so I will wrap this up soon. I think we'll be able to just finish it in time. So there we are, distance, people, wonderful. If we can fit all the people in the car, so if the number of people is greater than or less than the number of seats, self.self, that doesn't mean very much, does it? Self.seats. Lovely. Then we want to return, and here we're just going to call the parent drive method. So super, again, remember, gives us the parent object, or class kind of, and we can drive the parent just the regular distance. So we don't really need the number of seats. Doesn't matter if we can fit everyone in, that's fine, just drive. If we can't fit everyone in, which will happen if we don't return by that point, then we'll have to print our little error message down here. It'll say the self.model, so that's again the name of the car. Now it is a car. Didn't have enough seats for the journey. Lovely, and we'll go ahead and save that and run this, and now we'll be able to see that when we have our car there, a 4-seated car, now when we call drive, it'll say, hey buddy, the drive version's changed, you need to give us a number of people because we're calling it on the car. So okay, fine, we'll try driving with 2 people, in which case it'll do what it did before, because it'll call the super method, and it will just say the Nissan drive 30 miles in 30 minutes. However, if you try packing in too many people, 5 people in your little 4-seated car, the Nissan did not have enough seats for the journey. So that verifies that it is calling this new version here. Awesome. Cool. There is the completion of our little program. Are there questions about everything that we've done there? Because there's quite a bit. And I'll ask in a poll as well. Overall, how are you feeling about object-oriented programming in Python? There we are. Let me know how you're feeling. In the meantime, I will grab our feedback link. Copy. Wonderful. One person's feeling all right. That's good. We didn't lose everyone. Sorry, I'll bring back the code here. G people, cool, awesome. Loving the okay hand. Very nice. Cool. Yeah, so we'll be able to get a lot more practice with this, I think, as we go on in these future sessions, doing some machine learning things, and I'll try and be a bit more prepared and sharper on those. When declaring a class, you need the brackets after the class name if there are no arguments passed into it, i.e. class vehicle. Yes, so, I think older versions of Python 2 required you to always have the brackets. Here, the brackets are optional. So you notice vehicle has no brackets, but what this really means, it's a default. It's the same thing as inheriting from, I think, just object, which is this object class. So it's the base of the object class hierarchy. So this is identical to having no brackets at all, just like that. So that is definitely optional, which is good to know. Oh, and also the last thing we can do is we can take a look at the help for our car, because this shows us all sorts of interesting information. It shows us shows us the constructor. It also shows the method resolution order. So it says first it looks at car, then it looks at vehicle, then it looks at object. Because remember I said that all classes come from this object thing by default. So vehicle is it's inheriting from object. And you can see init was defined here, and so was drive. And from vehicle it's inherited the refuel. And from other things, yeah, I guess it doesn't really show the ones that inherited from object. I'm not sure if object actually has methods, but yeah. Awesome. Does that answer that question you had? It was a bit waffly. And I'm also sending along the feedback, so you can all roast me. This time I'm passing it to you beforehand, so you can roast me now, and you don't need to come back to the website or anything later. Awesome. Cool. I'm around for questions. If there are no questions, then I will send you all off, and thank you for coming along. It was lovely having you, and hopefully I'll see you for some machine learning next week. And don't forget, if you want to overthrow my rule, which would be very welcome because I'll have a very busy next year, run for committee. It's not too hard, and it's really fun, and you can do that in April. And I'll get back to you with the exact day later. But yeah, cool. And I will answer, and see you all, and I will answer Ben's question. With the class variable on the road, when you reference it in the init method, instead of writing vehicle on the road, could you use CLS on the road? Yeah, so that is something I don't think you could do right off the bat. Well, mainly because CLS here is not defined. It only gets passed to class methods. That would certainly be the nicer thing to do. I feel like there is a better way to do this where you don't have to explicitly type or vehicle there. The honest answer is I couldn't track down exactly what that method was. So maybe there's not a better way, but I'll double check. I'll do a quick Google search for you. We'll do that in a Firefox here. So let's see. Setting class variables in the Constructor Python. We'll see if we have any luck there. Initializer, so yep, you can set them there. That makes sense, fine. Yeah, so that's kind of the one I saw earlier, which looks really gross, and you have to use foo anyways. And I don't know if that's the only thing you can do there. Yeah, so maybe there's not a nicer way to do that necessarily, but I feel like there should be. There's an elegant way to do this. What's the elegant way? Well, that's a totally different question. Okay, so the answer, I think, is I don't think so. I think, unfortunately, you have to do vehicle here because class is only passed to these class methods. But it might exist. I'll probably do some further digging because it's bothering me now as well. And I'll get back to you probably on the Discord or something if that's all right.
Yeah, that sounds great. Thank you.
Awesome. Lovely. Cool. See you next week probably then.
Yeah, I'm looking forward to it. Bye.
Awesome. Sounds good. See you then.